Good morning, good afternoon, good evening, everyone, from whichever part of the world you have joined in from. Thank you for joining the webinar and sharing your valuable time in order to listen to our webinar. I would like to notify all the attendees that you would be on mute throughout the webinar session. So if you have any queries or questions about the webinar, so you can kindly mail to us at contact@simcondigital.com or to me directly at ankush.bose@simcondigital.com. You can also fill the contact us page or message at our social media page, and we will get back to you in 24 hours. So before we start this interesting topic and introduce our speakers, I wanted to give an overview of why we have selected this topic. So even with the advancements in IoT technology and the sensors making almost real-time data management, 40% of industrial organizations in USA feel their capabilities are limited and they still rely on manual processes to identify the functioning of the machines. For anomaly detection, it is imperative to collect data. However, only one-third of the industrial organizations are collecting half of the required data possible. These numbers tell us that many organizations are still in early stages of addressing this digital anomaly, as data is likely to be a key part of the digital transformation. And that is where CIMCON Digital comes in. So we make digital happen. So CIMCON Digital is a leading edge IoT machine anomaly detection and diagnostic platform and product organization. We are a 33 years young and reputed organization with over 200 plus engineers and R&D teams and have a proven track record of connecting assets in various industries, starting from manufacturing, energy and utilities, smart water, and other industries all over the world. We believe in the simple formula of make and save money, making in terms of new products and solutions, which in turn will help the OEMs, system integrators, and the end customers to save money in terms of reduction in cost of operation, increase efficiency, reduces downtime, and increases productivity. And we have proven and tested solutions in Fortune 500 companies all over the world. When we talk about enabling digital transformation, we talk about using technologies to continuously evolve all aspects of the organization. So as I said before, we work in varied industries and manufacturing is one of them. Our CIMCON iEdge IoT platform helps to increase efficiency and asset availability and have various use cases in predictive maintenance and quality analytics. We are also working in smart water sectors for more than 2 decades and have implemented various sensors like flow, pressure, energy meters in order to get valuable insights and increase the efficiency of the plant. Pump anomaly detection is also one of the solutions we are working on, and our speakers today will dive more deeper into this topic. We are also working on various smart building technologies where we integrate all building assets, sensors, and appliances in our Edge IoT platform. So now, without any delay, let me introduce our two speakers for today. So I am Ankush Bose. I am the Director of Smart Water Business for CIMCON Digital. Our second speaker with us is Mr. Prashant Kapadia. Mr. Prashant is the Chief Growth Officer at CIMCON Digital. He has 25 plus years of experience in industrial automation, Industry 4.0, and digital transformation. He's a thought leader, public speaker, and passionate about digital technologies. He has served previously many prestigious organizations like GE Digital, Hitachi Vantara, and TCS in senior leadership positions. Our third speaker for the day is we have Mr. Subba Rao Ganti. He is a graduate in mechanical engineering and a category 4 vibration analyst of Vibration Institute USA. He has 36 years of work experience in vibration monitoring of rotating machinery of oil and gas and power industries. He has experience in vibration data collection, analysis, and dynamic balancing of rotating equipment, including turbo machinery like steam, gas turbines, and centrifugal compressors. He has trained about 1,000 plus engineers in India and abroad in machinery vibration analysis, a member of the Vibration Institute USA since 1998, and has guided successfully about 225 plus candidates for category 2, 3, and 4 vibration analyst certifications from Vibration Institute USA in India and Middle East. Thank you so much, Mr. Prashant and Mr. Subba Rao, sir, for joining today's session. Before I hand over the presentation to Mr. Prashant Kapadia, I want to talk about today's agenda. So these are the today's agendas which we will be talking about. Like what are the problems the manufacturing world is facing today? Machine health monitoring, how to detect anomalies from machine health, machine fault mode diagnosis, and how can SIMCON Digital be your partner in providing this edge platform technology? So without any delay, I would like to hand over the presentation to Mr. Prashant, who will take over from here.
Thank you very much, Ankush, for this wonderful introduction. Good morning, good afternoon, and good evening, wherever you are in the world. So no one likes surprises, but it happens more often in today's manufacturing environment. Today we will talk about solution approach to avoid surprises and how you should plan a data-driven predictive maintenance journey. The idea behind machine anomaly detection has been around for decades. It focuses on identifying failure before they occur. A recent report by Global Industry Analyst states that with industrial consumers becoming increasingly concerned about rising maintenance cost and production downtime due to unscheduled breakdown of machinery, machine anomaly detection solution is gaining traction. Industry 4.0, digital transformation, and IoT technologies definitely help to accelerate its implementation. When talking about the problems in the manufacturing world today facing, it's very critical for you to understand that why machine anomaly detection are essential solution for your manufacturing facility or utility. We will talk about challenges in today's manufacturing or utility environment and why the current approach of operation and maintenance is not good enough to avoid higher operation and maintenance cost. Ankush, can you help me to go next slide? Yeah, thank you. So when coming to the challenges in a machine operation and maintenance, unplanned downtime is a reality. Unreliable asset of plant operation reduce the efficiency of the equipment, or it is a vice versa. These events lead to lower productivity. So it is very critical to invest in the right technology which provides actionable insight and foresight. Can you go to the next slide, Ankush? Yeah, sorry. And yeah, go back to that slide. Go back. Sorry. Yeah. And before I hand it over to Mr. Subba Rao, I want to just tell about why current approaches are not good enough to run machine at an optimum performance, and higher maintenance cost or lower efficiency are unavoidable with the present technology in a manufacturing industry. And same time, business environment demands do more in a less. New capex for equipment replacement is hard to get, and pressure to reduce OPEX cost is tremendous. And in this condition, we must look for the new approaches and invest our resources in the right technologies at the right time. So Mr. Subba Rao will cover about how maintenance practices evolved over a time, traditional approaches of machine health monitoring and its limitation, and how IoT technology shall help you to improve machine performance and machine reliability. Over to you, sir.
Thank you, Prashant ji, and thank you, Mr. Ankush, for the excellent introduction and then giving a good start for this excellent topic, which is a very important one in the present scenario of the industries, where the cost cutting is the word which is talked very often. And then the cost reduction comes in the form of reducing not avoiding the maintenance activities, but reducing the maintenance costs. So from that point of view, these technologies is going to help us to uh, look at how we can work upon this particular aspect. Can I go to the next slide, please? Yeah, thank you. Actually, the maintenance strategies for rotating machines in any industry is an important aspect from the point of view of that to sustain the production and maintain the profit bottom line. And then the traditional practices for rotating machines have been reactive or corrective or breakdown maintenance. That's the first type of maintenance which existed in the initial stages when we had on the rotating machines. That is running the machines till they fail and then fixing them. Obviously, it's a very costly affair, and then it involves a lot of production loss and then spares costs, etc. Subsequently, the strategy has shifted from reactive maintenance to a time-based preventive maintenance, wherein the machines were stopped at regular intervals, inspections were carried out, and if any impending problems were identified, rectified, so that the machine doesn't give a surprise failure. But again, this is also a very costly activities from the point of view of that you never know how much is the actual required time for machinery, and it results in excessive spare cost, and then the consumables cost, and also the manpower for doing the preventive maintenance. Subsequently, then from the preventive maintenance, people switched on to condition-based maintenance for these rotating machines. Condition-based maintenance fundamentally depends upon certain parameters of these machines, which give us an idea about what is happening on the machine. So monitoring those parameters and then identifying and the changes that are happening on the machinery is the fundamental concept for this predictive maintenance, time-based, condition-based maintenance. So in that process, what happened was that vibration monitoring has been found to be a very useful tool, very cost-effective and highly reliable tool for doing this condition-based maintenance. And again, the condition-based maintenance also is not trying to give us, it is only just like we are identifying the faults when they are coming, but we wanted to go in for a predictive or a more proactive type of maintenance. That's where this present technology is trending towards, with the utility of the advantages which we are gaining in the improvement of the technologies that are happening in the world now. Can I have the next slide, please? Here I would like to touch upon what is the present traditional or the present way the machine health monitoring system is existing in all the industries where rotating machines are existing. Fundamentally, it consists of three elements: the hardware, software, and a subject matter expert or a vibration analyst. So these are the three key elements in carrying out the machine health monitoring through vibration analysis. So the hardware consists of the sensors which are mounted on the machine. For those critical machines, we have a permanently installed sensors which are continuously evaluating the machine vibration, and then continuously evaluating the machine vibration, and then the software to capture the data and do the do the analysis. And then we have a an analyst.
Slide back.
And we have an analyst to take care of the data that is accumulated to find out what is happening on the machine. So these are the three elements.
Yeah. Yeah. Thank you.
Sorry for the interruption. So now, in continuing my accounting, the lecture here, So what we have, as I told you, three elements are the hardware, software, and the subject matter expert. Now, this is the way the traditional, even now, as of now, many organizations are handling the vibration monitoring in this fashion. So you have to have all the three elements in place in order to get the best output of it, and do reduce your maintenance costs and increase the machine availability. Now, the advancement of the Internet of Things, and then the latest developments in the hardware and software capabilities have started giving a very positive way of handling these things, integrating a lot of activities, and then bringing down the cost drastically, and at the same time increasing the quality of the activity. Can we go to the next slide, please? Now we shall briefly look at what is this machine health monitoring happening, how it is happening in the light of the new technology that is emerging. Now, as I told you, the three elements are independently existing separately, and now here in this modern era, we are integrating all of the them. So you need not have the human intervention in the form of a specialist. The thanks to the machine learning and the artificial intelligence concepts that have taken the industrial world by storm, and then they are being very well utilized in this particular activity. The hardware and software are already existing, but these artificial intelligence and the machine learning are coming to a rescue in order to integrate all these activities. And that's one, we have all the three in one here. So we have the sensor, the software which collects the information, and then the analysis, the algorithms that do the analysis, all are integrated into the one. And then the customer he'll be simply informed about what is happening on the machine, what changes are happening, and what are the likely reasons for the changes that are happening, and what maintenance actions he need to plan in order to see that the machine availability is maintained of very high levels. So I think this is what the present technology is trending towards, and then and helps in monitoring your rotating machines, increasing your availability, reliability of the machinery, and bringing down the unplanned maintenance activities. Prashant, I would like you to take over from here now.
Yeah, thank you very much, sir. So thank you very much, Subba Rao sir. I think you talked about your experience, decades of experience in vibration, and I think you have covered very well that how technology can help to reduce the cost of maintenance, and how integrated solution, hardware, software, and SME will help to detecting the problem early, and that's a value this technology can provide. And now I would like to tell you that industry leaders already started implemented this solution, and they started getting benefit out of this solution. And you can see here amount of benefit they started receiving in a different area. Let's say in terms of availability, they could able to improve 8 to 10% increase in availability. They could able to reduce 10 to 40% reduction in reactive maintenance, and they also able to improve 10 to 15% in labor productivity. So they already started getting benefit out of this technology. So technology is maturing, where customers started getting benefit from this technology. So Ankush, can you go to the next slide? Yeah. So now I will talk how CIMCON Digital Machine Anomaly Detection and Diagnostic Solution helps to provide insight and foresight for the machine that helps machine operator to reduce cost of maintenance, increase uptime, and labor productivity. And this solution provides question for Ankur, let's stay there. Yeah, thank you. So this solution will provide answer to the three critical questions. is my machine healthy or abnormal? Second question, what parameters contributing to the abnormal behavior? And third, which machine fault is progressing? Can you go to the next slide? Ankush, can you go to the next slide? So if you see this solution, anomaly detection solution journey starts with collecting sensor data. The machine provides tons of raw data from the sensor attached to it. It's critical to collect, integrate, and analyze and visualize in a various contexts. Better detection reduce mean time to failure and significant improvement in the machine operational efficiency. Fault diagnosis and prognostic is the goal in a journey. Better foresight and insight will provide a competitive edge to the organization. Ankush, can you go to the next slide? Yeah. And now question comes how this solution works. So it's very simple, straightforward solution where you can connect your sensors, existing sensor, flow or pressure or temperature. We will also help you to install new sensors, vibration sensors, and now smart sensors available where you can connect over wireless medium, either Bluetooth or Wi-Fi or Zigbee, and you can also connect your data from PLC or energy meter using Modbus or TCP/IP or any standard industrial protocol. So once data is available, now it's required to normalize and check for the quality and then also do the transformation. So that part of normalization and transformation of data will take care by edge platform. And then we can visualize in a different context, maybe at an enterprise-wide bird's eye view, and then you can go to the machine history, and then you go to the machine status, where you can see the data in an individual KPI card. So, Ankush, can you go to the next slide? So now question comes, where is the need for IoT platform for the predictive maintenance? Now, it's very critical to understand that predictive maintenance is a journey, and the right technology architecture plays major role to make you successful. Life of typical machine in industry is 20 to 25 years. So essentially, you have to connect legacy system along with new vibration sensor or wireless sensor. You also require to connect data from those automation controller or energy meter. And then you require platform to build solution, collecting, integrating, transforming, and building the context and create different visualization as well as analytics is very crucial to understand the data and create the intelligence out of data. So IoT platform can meet all the requirements in a simple, secure, and straightforward way. Also, it provides capability to integrate multiple technologies. So today, your use case may be simple visualization of machine data, but tomorrow you might require to integrate augmented reality, virtual reality for machine maintenance. Tomorrow might you have to integrate equipment digital twin. So you require data from real-time as well as historical data from the platform. So as I told you in the start, architecture for the implementation is very, very critical if you want to successful in an enterprise-wide implementation. And as your footprint grow, edge management provides remote management of the devices, because when you are installing for first pump, two pump, third pump, you may able to maintain going to the site. But when you start monitoring for enterprise wide, you can't go to maintain and monitor to every site, where age management functionality comes into picture. Sitting in a centralized location, you can manage all the IoT devices and you can monitor performance of those sensors. So definitely end-to-end age management solution provides very critical role here. And CIMCON has developed and designed this age IoT solution platform with 30 years of industry automation experience. And it has industry vertical wise microservice catalog and also provision containerized application execution. This helps to run or execute your application 4 to 5 times faster, and that definitely help you to increase return of investment time. Ankush, can you go to the next slide? So now you can see step by step application view. And first step, or I would say wave one, is to understand as-is analysis, real-time monitoring of machine behavior in a various contexts, or machine fault mode, or performance in a different enterprise application context is very, very critical to understand the machine performance. In the most manufacturing or utility environment, the opportunity window for correction is very small. So it is very critical that remote monitoring solution should provide actionable intelligence and drill down to the contribution parameters. And that's also quickly pointing out the correct parameter which help you to identify root cause and plan for correction and rectification. The system will provide where to look or which contribution parameter very quickly. This helps as a machine engineer to prioritize tasks and spend time on the right job at the right time. Can you go to the next slide? So what is the next step in a predictive maintenance journey? Of course, once you have a data available, then you can run various anomaly detection algorithms and data science models, which provides alerts on the abnormal machine status. Data science models monitor all the parameters 24/7, 365 days. It's similar to your best operator looking into all machine parameters every 5 minutes. Example, when you are running centrifugal pump in your water treatment facility or your building facility, and system directs you that your x-axis RMS or bearing temperature is started increasing, and also directs you which particular fault may be started evolving, which help you to start observing machine very critically, and then prioritize work order based on the machine condition. Can you go to the next slide? So as I told you earlier, machine fault mode diagnostic is a goal in a journey, and using artificial intelligence and machine learning technique, detecting the smallest change in machine behavior is possible. It helps you to identify the component level fault, maybe cavitation or seal failure or misalignment, bearing wear, and that help you that which fault are progressing and what is the criticality of fault. That's again help you to prioritize your work order and prioritize your scarce resources to a right job and save the catastrophic failure and reduce the maintenance cost. Can you go to the next? So this is one of the success story I would like to talk here, and this is the customer, one of the largest water utility, and they want to reduce the cost of repair and improve the water supply services. And typically this customer has a want to reduce their cost of maintenance, but they had a lot of surprise pump failures in their water treatment facility and distribution area, and they depend on walk around inspection and vigilance of operator. Now how our solution help them? So we help them to connect their existing sensor, pressure transmitters, head pressure and flow meter. We help them to identify right location for the vibration sensor. We connected smart vibration sensor on their various pump and motor bearing and collected those data onto our platform and started providing them machine health KPI monitoring. Using our anomaly detection algorithm and help of subject matter expert, we could able to provide them early warning on the radial vibration of non-drive and bearing side. And this helped them to avoid unplanned machine failure, which cost around $100K, and that they could able to receive this benefit in a 1 month of installation. When we have further created the business case for them, their potential outcome from this system is reduction in increase in availability of the pumping system by 10% and reduction in reactive maintenance by 40%, and definitely reducing catastrophic failures and planning maintenance early, reduce them, increase them labor productivity by 15%. So these are the one of the example out of many systems we have installed, which gives you confidence that how technology is already helping to the client similar to you. Can you go to the next? So as Mr. Subba Rao also told, and I told a couple of times, that predictive maintenance solution is a journey, and journey has a couple of steps, very critical steps, that you should start collecting, integrating, transforming machine data, tons of sensor already available, tons of data available with the machine, but unfortunately we are only using for measurement and control, not for analysis and analytics. Then you should check data integrity and quality, which our edge platform can do using the data science algorithm. And then first step is to understand disease analysis. Descriptive analytics has a major role, and it's important to provide actionable intelligence, but equally important that how you will consume those intelligence. And that's where collaboration for the action based data insight is critical from the platform. And then based on all foresight and insight, you can prioritize work order, and then moving forward you can take your organization to become model based organization. And as I told you earlier also, there is a huge potential available which you can tap using this technology, which definitely you can increase efficiency of your equipment, so you can reduce the energy consumption as high as 20%. You can improve the uptime as high as 35 to 40%. You can reduce 50% fewer breakdowns and reduction in cost of maintenance. So these are the couple of thoughts and our experience we would like to share with you today. And Ankush, now I would say forum is open for question and answer.
Thank you so much, Mr. Prashant and Mr. Subba Rao, for giving such a wonderful overview. Subba Rao, sir, for giving an overview of the predictive maintenance and the IoT and machine health monitoring. And then Mr. Prashant digging deep into our Edge IoT platform and how to detect anomaly from the machine sensor data. So thank you so much for giving such a great overview about this very interesting topic actually, because anomaly detection, everyone talks about it, but it's such a big deeper into this object in this subject and talking about it, it's really very insightful. So I have some two questions with me, which have been mailed to me, and I wanted to ask to this forum. So the first question which was asked is you're talking about this anomaly detection and predictive maintenance solution, but considering there are so many factories all over the world and so many machines connected, uh, so how easy it is to implement this solution?
Yeah, Ankush, I think that's a great question, because ultimately benefits will be received from enterprise-wide implementation. Because earlier cost of sensor and technology was very high, and now with advancement in semiconductor technology, the affordability is increasing. Now, definitely question comes into you as a customer in your mind, that how fast I can implement so I can get benefit of the technology, and then I can reduce my maintenance cost and improve availability. So nowadays, now things are uh, pretty simple using the wireless technology. So now all the sensors, vibration sensors, mm, coming with the wireless technology. So you have to just connect the sensor with the help of subject matter expert. You have to identify now correct location of the sensor. Once you identify correct location, now also you can use the now virtual reality AR-based app, which help you to now remotely location of the right sensor. So once a sensor is installed, now using the Wi-Fi communication, you can connect those sensors to the edge platform. Once data started flowing, then edge platform, as I told you, has a pre-configured industry microservices. So typically start providing the insight as early as within a 2 hours of time. So one of the example I would say, we have sent the 8 device and sensors. Sensors are connected to a device, and within a 2 hours of time, we have connected at least two pump, and data started flowing. So once data started flowing and analytics is available on your screen, then you can start observing, and with help of subject matter expert and with help of the artificial intelligence and machine learning, you started understanding, and software started provide actionable intelligence. That's a I would say fastest way to implement this technology.
Okay, okay, great, great. So the second question which I have is on like we were talking about this edge platform, this IT edge platform, and how it has evolved over the years, and how in this era of predictive maintenance and anomaly detection, how important it is. We wanted to understand like what would be the value of this IoT edge platform in this predictive maintenance technology that we are talking about.
So typically, as I told you in my during my presentation also, that in industrial world, life of machine is now 20-25 years. So when you go to any industrial plant, manufacturing plant, you find now legacy controllers, legacy um, mm, systems, and you have to deal with them. Now when you put new plant, greenfield project, you have opportunity to put new system, wireless sensors, and even in old system, that legacy controller and new wireless sensor are going to coexist actually. Now every time when you have a typically large enterprise has a around 20-25 facilities around the world, and every facility built at a different time. Now you think how you connect those facility on a single platform. So you cannot have a different platform or different devices everywhere in the world, because otherwise you are creating another silo and you're creating another mess. But what is the platform approach is, all these devices connected either on a Modbus or either on other PLC protocol or OPC standard protocol or wireless or Zigbee or Wi-Fi coming onto the one single platform. So that is where platform play a role, because if you connect with every machine with a different device, then you can understand how you will maintain it, because every device has their own product life cycle. And then when you're connecting, let's say, hundreds of machines in enterprise wide, it's very difficult to maintain those edge devices also. So where edge management on a platform comes into picture, using the over the air firmware implementation. So tomorrow you have changed some logic, or tomorrow you have developed some new logic for bearing fault identification, or maybe your pump manufacturer has given you some new logic. You can, over the air, you can implement on a similar pump across the enterprises, whether it is in China or whether it is in Russia or whether it's America. So that's the power of platform. Okay, because ultimately, if you're running the old stuff, then you have to dispatch the engineer or crew to replace those new logic. Earlier automation, people used to do all the manual work. So that is the Edge IoT platform with the help of automation and monitoring technology will help you to implement faster, maintain easily. And with Edge IoT platform, one of the benefit, because nowadays cyber security is one of the major concern for all the customer, and no customer want to send data outside their four wall. So in an Edge IoT platform, data resides within their four wall. So that is a more secure way of Edge IoT platform you can look at. So there is a many more benefit, but of course I would say benefits are more easy installation, secured, and simple, straightforward implementation in this space actually.
Great. Thank you so much, Mr. Prashant. Thank you.
I can see one more question. Maybe Subba Rao sir can answer. So, sir,
Okay.
what do you think? So, I think he's asking, what do you think where this technology is more applicable, because vibration is not a new subject. So what do you think this has a great applicability, and where we should look, what asset we should prioritize for this technology?
Actually, see, as such, the vibration as a tool can be applied to any equipment which is rotating, be it a small pump or a motor, or to a large turbine, 500 megawatts turbine, gas turbine or steam turbine, a large centrifugal compressor. Vibration, conceptually, it can be applied to any rotating machine. However, looking at the way we are trying to develop this present scenario, this technology can be applied very comfortably to almost 70 or 80% of the type of rotating machines that exist, which are very common in all the industrial world, be it manufacturing or process industry or anything, like pumps, motors, fans, compressors of small size, etc. However, because of the complexity involved in the vibration behavior for large turbo machinery like steam turbines, gas turbines, centrifugal compressors, which you encounter in large process industries, oil and gas, and power stations, etc. That's where I think we need to work on a large scale, because the complexity of the vibration analysis is much higher over there. So barring those equipment, as I told you, maybe comfortably 70 to 75% of the industrial machines which are there, this technology can be very well applied, and then positive results can be easily obtained out of them.
Yeah, thanks for your insight, sir. And I believe those 70-80% of the machines are today are monitored by walkaway, walkthrough, or operator vigilance actually. So
That's
definitely
right.
this technology will add value quickly for the client. And as I told you, affordability of this technology is increasing day by day. So that's another advantage, to get quickly return of investment from this technology?
The basic advantage comes through the minimizing the human intervention, the sensor. Once the sensor installed, everything is coming automatically. The diagnosis is also done to a large extent over there. So the daily, a person going to the machine, collecting the information and then dumping into the computer, and another expert analyzing the information and generating reports. This type of activities which involves both time and manpower, that is to a large extent brought down with this concept as such. So that's going to provide a lot of cost savings apart from the other advantages which the system is going to provide.
Yeah, thank you very much. Thank you, sir. So I think this covers everything, and because I would say
Thank
anyone has any
you.
question.
Yes. If anyone has any questions, so you can see the screen. So you can email us at contact@simcondigital.com, or you can directly mail us at our mail IDs. We have our head offices in Boston, Massachusetts, and we have an office in India, which is in Ahmedabad, Gujarat. You can also visit our website, which is simcondigital.com, where you will get all the insights about what industries we are working on, what technologies we are working on. And we are also very active on social medias. We are on LinkedIn, so you can follow our pages to get to know more about what our team of engineers and R&D team are doing in the latest technology and developments in IoT edge platform and other anomaly detection and predictive maintenance technologies. So thank you everyone for joining in and giving your valuable time. Thank you, Prashant. Thank you, Mr. Subba Rao, sir, for giving your valuable time. And yeah, I hope to have a good day.
Thank you, gentlemen.
Thank you very much. Thanks, Ankush. Thanks, Subba Rao, sir, for
Thank you.
a nice day.